Hey guys, welcome back. Today's lesson is lesson 116 and it's about solid shapes from a geometric point of view. Most of you are probably distracted by the board behind me, which one of my sons got a hold of. I'll let you try to guess which one, and you can email me and let me know who you think did it.
For extra credit, right? 50% of your grade, if you get it right.
No. So one of my sons consider math mental abuse to humans. So thought we'd start your day with that, but now we are going to erase that. All right, so a lot of today's lesson is a lot more vocabulary, but most of it you should know. So I'm just going to highlight a couple of them, but I do want you to read in the lesson all the vocabulary just to make sure you know it. I am going to draw. This lesson requires a lot of drawing. You guys know how I am about that. So I'm going to try to draw first a figure. Two parallel lines this way, and then I'm going to connect these edges, and then I'm going to draw another one. I'm going to draw like that and like that. Connect that edge. I think actually this is supposed to be a straight line down, so let's do that. Got to practice these. And then just to show the back, this front edge we can draw solid, but then to show what would be back here, we do dotted lines. Because technically if this is a solid, you wouldn't be able to see those back lines. Okay, so this shape is a solid, a geometric solid. That means it's three-dimensional. Okay, geometric figures that are solids are just three-dimensional. Three-dimensional. It has, each side is called a face. So this one has 6 faces. Has a top face, a bottom face, and then 4 side faces. Where the 2 faces come together is an edge. That makes sense. Where the edges come together at the points is called a vertex. More than one vertex is called a vertices. Those are some terms you should have heard, and they're all in your book. One you may not have heard yet, put an L in there, is called a polyhedron. A polyhedron, the definition of that is just a solid whose base is a polygon. Remember, a polygon is a closed figure that has straight line segments. It can't have curved lines. So this is a polyhedron. It is a 3D figure whose base, and by the way, this top part can be called a base, or this bottom part can be called a base. Those are the bases, and they are rectangles, which is a polygon. So this shape is called a polyhedron. Okay, next, this is also called a prism. Okay, a prism is a polyhedron where the 2 opposite faces are congruent and parallel. They're equal in size and shape, and they're parallel to each other. So this is also called a prism. And this is a rectangular prism because the bases are rectangles. Okay? We can also have a triangular prism, which is on the bottom of page 569. I'm not going to try to draw that yet. And that's just called a triangular prism because the bases are triangles. Okay? So polyhedron is a 3D figure that has polygons as the bases, And a prism is a 3D figure where the bases are congruent and parallel. Next, we talked about the bases. These sides are called the lateral surface. Lateral means side. I'll put that up here. Lateral surface. So this, and we'll put up here base also. So this figure has 2 bases and 4 lateral surfaces, because the lateral surfaces are the sides. So I think that's, the next one, we're going to leave that up there for a second because I don't want to have to draw that shape again. I'm going to draw another one over here. If you have a circle on the top, and we're going to draw this, and then if you were to have a circle on the bottom, this, it's the shape of a can, most of you know this, is called a cylinder. It is not a polyhedron because its bases, the top and bottom bases, are circles, which are not polygons. So a cylinder is not an example of a polyhedron, but it does have bases. The top and bottom are called bases, and this middle part is also called a lateral surface. So just sort of vocabulary there. A cone, you guys know what a cone is, has a circle on the bottom, and it's an upside down or a right side up ice cream cone. You can picture that. A sphere, most of you know what a sphere is. It is just a 3D circle or a ball. And technically the geometric definition of a sphere is every point on the outside is equidistant from the center. So an oval shaped ball is not a sphere. It has to be perfectly round. So now that we've done a quick rundown of all the vocabulary, what we can do with this, when we were looking at 2-dimensional figures, we could figure out the area of a shape. When we look at 3-dimensional figures, we figure the volume. Volume means when you fill up the inside. And volume is measured in cubic units, which we also know can be an exponent of 3. Because the idea is that you would be taking little cubes and seeing how many little cubes you can fill the inside of the shape with. And that's how we get volume. So we're going to look at some formulas for finding volume of polyhedrons, prisms, cylinders, all kinds of fun stuff. So let's look at page 569. They have a figure like this, and they tell us that this is 5 inches. The length of this edge is 9 inches, and the length of this edge is 8 inches. Well, the volume of a rectangular prism is the same. You know this formula. The volume just equals length times width times height. So we just do the length times the width times the height. And when we multiply that out together, 9 times 8 is 72. 72 times 5, 35, 360 inches cubed. You have to make sure you put your answer in cubic units. Okay? So you know that formula for volume already. Length times width times height. That should not be anything new for you. So now I have to try to draw this figure. Or actually I'm not. You look in your books at the bottom of page 569, you have a triangular prism. That means the bases are triangles that are congruent and parallel. And if you look at this picture in here, the volume of a prism, area of the base times altitude, yes. So the formula for the volume of any prism, we'll put that in here. My marker's running out of me, is the area of the base times the altitude or height. Which really, when you looked at, when we were doing the rectangular prism, the base was a rectangle. What's the formula for the area of a rectangle? Length times width. And then we just did times the height. Altitude and height mean the same thing, okay? So when we did the volume of the rectangular prism, the area of the base was length times width, and then we did times the height, the altitude. So when we have a triangular prism, the formula for the area of a base, the formula for the area of a triangle, if you remember, is 1/2. I have to look at my book to make sure I'm not telling you wrong, because I have a lot of stuff swirling in my head right now. 1/2 the base times the height. Now, this is where you have to be careful. When I'm doing a triangular prism, I am going to have to write this picture. I was trying not to, but I don't see how I can. All right, let's see how well I can do with this. I'm going to draw that, and then I'm going to bring a straight line down here, straight line down here, and I'm going to draw that, and these dots are representing the back that we're not supposed to actually be able to see if it was a solid. Not bad. And we have, this inside is 12 inches, this is 8 inches, these sides are 5 inches, and then it shows in here that this is a right angle, and that is 3 inches. All right, the reason I wanted to draw it is this. I'm using the word base twice in here. When I'm saying the area of the base in this formula, I mean this whole side and that bottom, the base of the prism. But when I'm talking about the area of the triangle, if I just look at this triangle and I say the area is 1/2 the base times the height, 1/2 base times height times altitude. I'm looking at this line, just this line, the base of the triangle. Okay, so when I'm doing the base of the prism, I'm talking about the whole side. When I'm talking about the formula for the area of a triangle, 1/2 the base times the height, I'm just talking about this line, the bottom of the triangle. I hope that made sense. So to put this in here, I have 1/2 the base of the triangle, which is 8, times the height of the triangle, not the altitude or height of the prism. Right now we're just looking for the area of this triangle right here. So the height of this triangle is 3. We're going to figure that out. Now we're going to multiply that times the altitude of the whole prism, which is 12 inches. So we know 1/2 times 8 is just 4. 4 times 3 is 12. 12 times 12 is 144. Our unit of measure is inches. We're doing volume, so it's cubed. Okay, I hope that made sense. All right, so, and really guys, this formula here, the area of a base times the altitude, is going to be how we figure out any geometric solid. In the next chapter, we're going to be doing cylinders, and we're still going to be using this same formula. We're going to be doing the area of the base, which is going to be a circle, times the altitude or height of the cylinder. So this formula really comes into play because all you're going to plug in here is the area of the shape of whatever base you have of your prism. So, let me make sure I covered everything I wanted to there. Yep. Let's look in the book. In the book. Look at, oh, I did forget to cover one term that, again, you probably know. A pyramid. You can picture a pyramid. When I say pyramid, most of you are probably picturing, say it out loud. What do you pick? Even though I can't hear you, what are you picturing? Hopefully you said the pyramids in Egypt. Okay, you can picture the pyramids in Egypt. They have a square base, and each of the lateral sides are triangles coming up to a point at the top. That is called a rectangular pyramid. When the base of a pyramid is a square and the lateral sides are all triangles coming up together, it's called a rectangular pyramid. You can also have a triangular pyramid where the base is a triangle and then the sides come up to a point at the top. So, having quickly reviewed what you should already know there, look at letter B on page 571. It says, what type of solid is that? Well, it can't be a prism because a prism has to have two bases, a top and a bottom, congruent and parallel. And we see what shape is at the bottom. The base is a rectangle. And all the lateral sides come up into one point, one vertex, so it has to be a pyramid. So the answer is B, a rectangular pyramid. All right, letter C. Let's do letter C real quick. It's just like this problem we did here, except the measurements are different. So we'll just fill in those measurements. So look at that picture. The base, see that triangle at the base? We have to figure out the area of the base. 1/2 base of the triangle times height of the triangle. So it's 1/2. And we see that the length of the base of that triangle is 7. And we see that the height of that triangle is also 7. And now this altitude means the altitude or altitude of the whole prism up to the top. And that's 14. Okay? So here, I'm going to grab Zach's calculator real quick because he's filming on my phone and that's where my calculator is. So we are going to do, I'm going to do these first. I'm going to do 7 times 7 is 49. 49 times 14 is what I'm going to do in here. And I got 686. Now I'm going to divide that by 2. And the answer is 343. Look, the unit of measure is yards. And because it's volume, we're going to put cubed. Okay? Turn the page. Let's look at page 572. Now 572, letter D, is asking us to find the surface area. So what that means, when they're asking you to find surface area of something, that means, let's see, let me try to draw this figure again. We have another triangle. I'm going to put the sides. Okay. Make the dots. I don't know why that's curvy. It got curvy on me. And it tells us this line across is 8. This line across is 6, down is 6. The height of this triangle is 3. These lines are 5. Okay, surface area. When we were talking about volume, we were talking about filling up the inside of the shape. Surface area is if we wanted to cover with wrapping paper all of the faces, all of the outside of a shape. So the way we do that is this. This, we know the bases are triangles. So to figure out the area of that triangle, we do 1/2 the base times the height of the triangle. So we have 1/2 the base, which is this line. We know this line matches it, so if that's 8, this is going to be 8, times the height of that triangle, which is 3. That gives us 8 times 3 is 24, divided by 2 is 12. That is the area of just one triangle. But we know, because this is a prism, this triangle is equal to this one, so the area of this triangle is also 12. And I'll tell you in a minute why I wrote it there. The area of that, so if I wanted to cut out a piece of paper to cover that triangle, I would need 12 square units. We're talking about area, so it's square units. But now I have to do the lateral surface, the lateral part, the sides. This is a rectangle. So we know to find the area of a rectangle is length times width. Here's my length, or my, I guess, length and width. 6 times 8 equals 48. So this face is going to be 48, but I still have 2 more faces in the back. Well, the way that these pyramids work, they're all going to be the same as this front. No, they're not. They're not going to be the same at all. So, the way that we're going to figure out this face and this face, we know if this is 6, this has to be 6. And see this length here of 5? So that back face is going to be 6 times 5. So that back face is 30. Let's look at this one. The one that connects this line down to this line is also 6 times 5, which is 30 again. So when I look at this pyramid, it has a total of 5 faces. The base at the top, the base at the bottom, a lateral side here, a lateral side from this line to this line, and a lateral side from this line to this line. So I figured out the area of this surface plus the area of that surface, the area of this front rectangle, the area of that back rectangle, and the area of that back rectangle. Now we add them all together. We add all these numbers together. We get 12 plus 12 is 24, plus 48. I'm not going to even try to do this in my head, even though I should. I have 24 plus 48 plus 60. I did 30 plus 30. 132. We don't know the units, so we do units squared. Whenever we talk about area, we do squared. So surface area, you just figure out the area of each face, then add them all together. All right, true, false questions, then we're done this lesson. Number 1, page 572. A cone is a solid with 2 bases that are congruent and parallel circles. That is false. If you picture an ice cream cone, there's only one base. The other side is a point. So that's false. Number 2, a cylinder, which is like the shape of a can, is a polyhedron where 2 faces are parallel and congruent and the remaining faces are all parallelograms. Again, that's false. Because a polyhedron, the bases have to be a polygon, and a circle is not a polygon. So a cylinder that has circles as the bases cannot be a polyhedron. Okay? If you have any questions, email me and I'll get back to you. See you in the next lesson.